Voltage, vitality, elevation.
Have you ever looked up at the night sky and felt a spark of wonder, wondering what unseen worlds drift beyond the stars? Imagining rogue planets, massive solitary giants, wandering unseen through the galaxy. In this journey, we push past the familiar, driven by a burning curiosity to uncover the science, the possibilities, and the breathtaking wonder of these hidden worlds that wander our Milky Way galaxy. Somewhere in the vast ocean of space, a planet once bound to a star was flung from its home. Imagine it, a solitary sphere, untethered, drifting through the cosmic void, never again feeling the warmth of a star. But how does a world like this come to be? Perhaps by a massive gas giant with immense gravity, or through close encounters with massive stars, a rogue planet can be torn from its orbit, its fate sealed by a sudden gravitational jolt. What kinds of stars could do this? Perhaps a red giant, flaring with power, or a passing binary system whose gravity destabilized it. Could life, hidden beneath frozen oceans, or in buried planetary energy, still rise on a world like this? What if, in some distant future, a rogue planet drifts into a star's gentle gravity? Could it reignite, sparking a new dawn where once there was only darkness? As we gaze into this abyss, we picture these cold wonders and realize that every rogue world carries a possibility, a future waiting in the cold, dark expanse. In the delicate dance of celestial bodies, a planet's orbit is a fragile harmony, sustained by the balance of gravitational forces. Yet even this balance can be upended when a massive star, like a supergiant, moves in a distant part of the galaxy. Its gravitational pull can stretch and twist a planet's orbit. Over time, sometimes just millennia, this tiny nudge accumulates. Gradually, a planet drifts beyond its star's grasp, entering a dark, solitary journey. Even smaller planets, once held tightly in the outer reaches of a system, can be easily dislodged if a passing star's trajectory crosses theirs. And what's remarkable is that these events may have been more common in the early universe, a primordial chaos of young stars and wandering planets. Thus, each rogue world is not just an accident. It's a survivor of cosmic upheaval, a testament to the unpredictable power of gravity, shaping worlds and flinging them into the dark unknown. In recent years, astronomers have actually begun to detect these rogue exoplanets, worlds drifting unseen, untethered to any star. Using gravitational microlensing, scientists have glimpsed these dark wanderers, sometimes as massive as Jupiter, sometimes smaller, like Earth. What's astonishing is that some of these rogue planets appear in regions where no star once held them, free-floating in the galactic halo. Could some of them perhaps be remnants of destroyed solar systems? Or might some have formed alone, born in isolation, waiting for us to catch a glimpse of them in the dark? Each discovery adds a new piece to the puzzle and reminds us just how vast and still unknown our cosmic neighborhood truly is. By measuring the slight bending of light from distant stars when a rogue planet passes between us and that star, astronomers can infer the planet's mass and distance. In fact, some of the most intriguing rogue planets lie far beyond any known solar system, billions of miles from the nearest star. What's more, theoretical models suggest that some may even hold traces of primordial atmospheres, ancient and untouched by a parent star. Could these worlds be the last remnants of cosmic storms, each a time capsule, a frozen record of a universe still unfolding? Each discovery pushes us to reimagine not only planetary formation, but also our place in a vast, ever-expanding cosmos. Life in the dark. Could these rogue planets, adrift without a star, still harbor hidden warmth beneath their icy shells? It turns out they might. Deep within some planets, radioactive decay in its rocky core releases steady heat, keeping water in a liquid state beneath layers of ice. In some cases, tidal forces, if a distant gas giant orbits nearby, can flex the planet's interior, generating even more energy. Scientists speculate that in these hidden oceans, shielded from starlight, primitive life might arise, like extremophiles on Earth, adapted to darkness, pressure, and heat. What if these worlds, silent and unseen, are not just barren wanderers, but cradles for a life we have never known, waiting in the dark? Even without a star's warmth, a rogue planet can retain an inner warmth. Radioactive decay in its rocky mantle releases steady heat, warming pockets of water beneath a thick crust of ice. These slow reactions can generate enough energy to sustain liquid water oceans, perhaps even allowing simple life forms, like those we find in Earth's deep sea vents, to evolve in secret, hidden from any star's glow. Scientists now believe that our galaxy may harbor more rogue planets than even stars, trillions drifting unseen in the vast emptiness between. Using techniques like gravitational microlensing, astronomers have detected subtle bends in starlight as these unseen planets pass between us and distant stars. By mapping these faint signals, they estimate that for every star we see, there could be dozens, perhaps thousands of these hidden giants. Without a star, these worlds drift silently, but their sheer numbers suggest that the galaxy is more diverse and more dynamic than we ever imagined. What mysteries lie on these dark wanderers, silent behemoths carrying the untold stories of a galaxy we are just beginning to explore? These rogue planets, untethered from their parent stars, could be ancient wanderers from long-lost systems, survivors of cosmic cataclysms. They might have formed in the galactic disk and been flung out billions of years ago, or maybe some never knew a star at all, born in the cold, dark clouds of interstellar space. And as technology advances, next-generation telescopes, and more precise microlensing surveys, we might uncover that these rogue giants aren't just outliers, but a fundamental part of how worlds form and migrate. In every dark corner, we realize, there lies a potential history, a giant waiting to reshape our understanding of the cosmos. Since these rogue planets don't emit light of their own, we rely on subtle gravitational effects. As a rogue planet passes between us and a distant star, it bends the star's light. This phenomenon is known as gravitational microlensing. By carefully measuring these tiny brightness changes, by analyzing those brief subtle shifts in starlight, astronomers can deduce the mass and distance of these hidden planets. Sometimes, a single event can hint at one world. Other times, repeated detections suggest entire populations. And with next-gen surveys, like those from the Roman Space Telescope or future arrays, we might soon chart entire fleets of these giants, dark, massive, and waiting to be discovered. As we close this journey, we realize that we, too, are like these wandering worlds, untethered, searching for purpose in a vast universe. And just as a rogue planet carries the potential for life beneath its icy shell, so too do we carry infinite possibilities inside us. So, as you step away from this exploration, remember, we are all seekers, drifting toward a future full of wonder, waiting for us to light it up with our curiosity and courage. Thanks so much for watching. Be sure to like and subscribe so you don't miss a thing. What do you think about rogue planets, these dark planets that wander the Milky Way? Let me know in the comments below. Stay curious, guys. Stay electrifying. And always stay elevated.
Thanks for watching Voltage Vitality Elevation. Please select one of the videos displayed on the screen to continue watching.